Hello students, now let me explain dispersion, angular dispersion. Okay, the derivation of angular dispersion. In my last class I've already explained you the concept of dispersion. Now let me explain the derivation of it. Okay, so as you can see over here, dispersion is a phenomena in which the white light splits when it passes through the prism, splits into its constituent colors. So in the picture you can see we have chosen only the extreme colors, that is violet and red. Okay, as it splits into Vibgyor, so you can see the violet color deviates the most compared to the red color. Red color deviates the least. Okay, delta V and delta R is the angle of minimum deviation. Okay, for this violet light and this for red light. Understood? So we want to know the angular dispersion. So as you can see over here, the definition of angular dispersion, it says that the angle between the emergent rays of any two colors is called the angular dispersion. Okay, so we have chosen the violet and red color. So these are the two emergent rays. You can see the angle between them, which we can find it if you produce it backward. Then you can see this theta. Theta is the angle between them. These two emergent light. Okay, that angle between them we call it angular dispersion. So in this picture, theta is the angular dispersion. So we want to calculate the theta. We want to know the formula for theta. So theta can be simply written as delta V minus delta R. Okay, looking at the picture you can see. So we can write the theta as delta V minus delta R. Well, delta V is the angle of minimum deviation for violet color, and delta R is the angle of minimum deviation for the red color. Okay, so that's the definition. That's the formula for angular dispersion. Okay, now again we know in our last class previously I've already derived the formula for delta. Okay, angle of minimum deviation for thin prism. Okay, it is eta r minus 1 into a, where eta r is the refractive index for red color, a is the angle of prism. Okay, so similarly for delta v we can write the same thing. Okay, we have already write this in our last class. Okay, so we replace this value, this two value for delta v and delta r over here, over this equation of theta. Then we finally get theta is equals to eta v minus eta r into a. Okay, so thus the angular dispersion, that is theta, produced by a prism depends upon what? Depends upon the material, because it depends upon the refractive index. Eta v and eta r are the refractive index, material, and as well as the a, which is the angle of prism. Understood? Good. So you should remember this formula. Okay, this final formula for theta.